In this video, I want to show you how useful and interesting it can be to try to spy on the traffic that comes out from programs like Docker or kubectl. And especially for kubectl, because there is a ton of things going on in the background. There is a ton of requests being made to the API server, and I really wanted to know what was happening behind the scene. So I found out this blog written by a person in October 2019, and it uses mitmproxy, which is a proxy that shows you the requests that have been made to this proxy and that are proxied. And the trick is that, kubectl, the API server uses two kinds of authentication, and in this blog post they use the token authentication. So as we can see at the bottom, kubectl is connecting to mitmproxy that forwards the header, the authentication header. So it forwards the authentication header to the API server, and it works. So the steps are, first we start the mitmproxy and we disable the verification of the TLS certificate given by the server, and that's because we don't we know that the server, the API server. So let's create a kind cluster first. So this is a local cluster, and I won't create it because it already exists. And let's have a specific kubeconfig for this. So what this does is keep the verification, because this cluster that I just created has a self-signed certificate. So when we're going to connect to it, the client, which is kubectl or mitmproxy in this case, is not going to be able to verify this certificate. And then we can hit the proxy using kubectl. So we use HTTPS proxy here, and that should work. And we also disable the TLS verification for kubectl because mitmproxy is going to give us a certificate that is self-signed also, and we don't want to bother with this. We could pass the cert to kubectl, but yeah, let's just keep it. But the problem is that in this blog post they are using tokens, but I don't want to use tokens. The default kubeconfig for a kind cluster is going to be a client cert kubeconfig. So let's see what we have in the kubeconfig. And as you can see, we have a client certificate data and client key data, which is the pair that is going to be used in order to establish the mutual TLS handshake. And we can also see that the address for the API server is the loopback address, which is unfortunate because when you use kubectl and when you use any kind of Go program that you want to use a proxy with, so when you use HTTPS proxy here, and that the address that it is trying to connect to is a local host or 127.0.0.1, for either of them, it's going to not proxy the request. So I'm going to show you a bit later how I did this. So let's go back to my local cluster. As you can see, so by K, I mean, so I have alias K, for kubectl. So K get nodes gives me the only node, which is the control plane. And what I can see is, let's see the logs for the scheduler, for example, just for fun. And so we can grab the logs. And what I want to see is what kubectl does to get the logs, what happens behind the scene. So the first thing that I have to do is so grab the certificate, the client certificate, and put it in a PEM format file. So what I do is just grab the client key certificate and client certificate data, and I decode them and I put them both in this client.pem. Let's see what is inside. So the private key and public key. And then we can go ahead and run mitmproxy. And we tell mitmproxy to connect to the API server when we will connect to it. So it will present these client certs. And let's create another shell. So if we use HTTPS proxy at this point with, for example, get nodes. Oh, that's interesting. What happens? Oops, sorry. Let's try again. I forgot to set the kubeconfig. So let's make sure we are using the right kubeconfig, and yeah, we have the right one. So let's try again, and it doesn't work. The request is not forwarded, is not proxied, and that's the thing that I mentioned earlier. This localhost is not being proxied by Go programs. So what I do is a tiny trick, which is kubeconfig, and I change a bit the kubeconfig in order to make it work. So if we do get nodes this time, okay, so this time there is this validation. So when mitmproxy sent us its self-signed certificate, it wasn't able to verify it, and because obviously the kubeconfig here, the certificate that is used to verify the certificate sent by the server is this one. So what I do is insecure skip tls verify, and let's run the command that with the logs that I did previously. So first get nodes, and as we can see, it's doing a ton of things because it's fetching all the API, open API files and all the information needed in order to make the calls. And finally get the nodes. So we can see the get nodes here. And yeah, this is just the column information, and then again the column information. That's interesting. And here we have the actual object, I think. Interesting. It is the response is not the one I was expecting. Anyway, let's do the same for logs. And oh, by the way, the red thing here is due to the fact that, as we did before, we enabled SSL insecure or something like this, and so it's telling us that obviously the self-signed certificate given by the API server cannot be verified, and that's expected, but it goes on and it still makes the request. Yeah, so we can see that we can see the logs, and if we do the follow, we can even see that, we can see that the request never ends, so the TCP connection still is going on. And if we stop it, it still doesn't shut down the connection. That's unexpected. It should eventually see that the TCP connection is done, I guess. Let's see what we have in the logs. Here, content missing, okay. And we can see there is one query parameter, and we can see a couple of headers, response, and yeah, things. Oh, interesting. It's also showing the common name for this API server. For the API server certificate. So we can see that you can connect to, you can use all these hosts, but obviously I'm skipping the verification, so I don't really need this. I'm not using this information anyway. Oh, and it's using HTTP2. That's I wasn't aware of this, but it's weird. It's in plain text. Yeah, maybe I'm not really aware of HTTP2. Anyway, that's everything I wanted to share. So thank you very much for watching this, and goodbye.